Okay, let's see if we can start streaming. Do I need to select a different microphone or something? I don't know. Just increase the volume because I'm speaking softly and that should be fine. Let's actually test the audio. Let's see. Yeah, we'll test this new thing. Yeah, if you have any questions about the previous content, go for the chat. Yeah, I'll show this behind the scenes real quick. This is what we're currently using for the setup. For developing. We're not gonna look at the code. We don't really care about the library. Oops. We only really care about this thing here, which is model. Agent. Agents are coming. What a time to be alive. That's borrowing, not stealing from another YouTuber. What a time to be alive. That's all I remember from that YouTuber. No, I'm kidding. It's pretty good. It was a 2-minute 2-minute papers. Yeah, go check it out. Plan. So we have this plan agent. Wait, what just happened? I clicked on it. Pylons MCP7. No, we're not connecting that. So did it just... Right. So the selected tools are configured by the plan custom agent. Changes to the tools. So it's essentially select a different set of tools when we click that planning agent. What changes to the tools will only be used for this session and will not change the plan custom agent. How do I select the agent? Mueller? Right. So they added this new thing. It's the session there on the top. Not sure. Anyway, the user interface doesn't matter. Default approvals, set permissions. Copilot uses configured settings. All tool call are auto approved. Bypass approval. That sounds like safe, doesn't it? Bypass approval. Autopilot preview. Autonomously iterates from start to finish. It's just gonna like chew up the tokens though, wouldn't it? So that's we'll do the default approvals. Yeah, running it locally. Learn about agent types. Yeah, I don't want to learn about it. There will be a lot of content on YouTube that I'm sure that you can go check out. And it's looking at what's currently open. Yeah, we had some old prompts for things. Yeah, I want to really test it with something simple. How it can deploy. How do we simulate like accelerometers on a smartphone device? Pin selection. Can you just remove it? No. So it needs a file. Okay, hopefully we will be able to show some output. I will generate something in the meantime. We'll just have Notebook LM doing a review. We have this BioChaos interactive biomedical engineering with two sources. It has the YouTube channel and the. If you refresh the page, in the video, can I just use a screen grabs from only use screen grabs from BioChaos.com? I'll just say BioChaos content. Let's see if it can do it. I'm not sure. Let's do a quiz. Quiz. Let's make it. Should we make like an easy, medium, and hard? Yeah, the quiz is actually pretty good. Let's do an easy one. I'm sure it can. I'll do a medium one. It's not generating different names for it. Let's do a hard one as well. It's not generating different names for the quizzes. We're also doing a video. Yeah, and we have a normal messages. Where are they? Oh. Yes, did you know that all the tools we develop are available freely on BioniChaos.com? And there is a human in the loop. If you have any questions, I'll keep repeating that often. Okay, we have biomedical quiz, neurotechnology quiz, and bioengineering quiz. Which one was generated first? Should we do it top to bottom or? Okay, let's do them one by one. What technology does real-time signal amplification microscope use to detect heart rate via webcam? That's kind of in the name. It's a Eulerian video magnification. It's not doing anything acoustic. It's not doing galvanic skin response. No, infrared thermal imaging. We don't have an infrared camera. If anyone wants to send me an infrared camera, you're more than welcome. More than welcome to. But no, it's a Eulerian video magnification. So it's yeah, look it up yourself, see if it's working for you. I should be able to run it in the nav. In another browser. Wait a sec. Yeah, go buy a microscope. Yeah, I don't know if it will be able. What do you think? Will be able to do my heart rate when the video is blurred out, or not? What do you think? Not sure. No, it's actually not able to. Does it? No, it gets something. It is getting something. But yeah, the signal quality would not be great. Let's move to the next question. Classic data science dilemma. According to BioniChaos YouTube post, what is the classic data science dilemma regarding raw data? Deciding which programming language? Nah. Because the AI can choose its own language, whatever. We should be language agnostic by now. Choosing between clean data and complex modeling. Classic data science dilemma. No, I don't think it's to do with choosing between clean data and complex modeling. Selecting between open source and proprietary software, maybe. Finding enough hardware to run large neural networks. No, it's actually is choosing between clean data and complex modeling. The source emphasized that while everyone wants to build life-saving products, the real bottleneck is the months spent cleaning messy, inconsistent data. Okay, it sounds legit. Sounds legit. What is the common experience for a patient when cochlear implant is first switched on, according to some post? Robotic sounds and confusion, perfect clarity of human speech, definitely not. Instant high fidelity music appreciation, definitely not. Complete silence until the software updates. That would be fine if you needed to wait for an update when turning a cochlear implant. But no, that's not the case. So yeah, robotic sounds and confusion, that sounds right. In the Fourier series visualization tool, how is a complex shape or pattern created? So it's actually It's actually talking about and there are a couple of them. There's two of them. To know which one. To know which one you wanna cover. Let's see. In the Fourier series visualization tool, how is the complex shape or pattern created? Well, there's one where you draw it. Where you can draw it, it will turn it into, break it down into Fourier components. It's the arrows there that you see, created with sum of rotating vectors, epicycles. So it's breaking up the shape, the 2D shape, into frequency domain by essentially, yeah, so if it was time series data, it would have been breaking it into Fourier transform. So you'll see the arrows, the arrows will be just vertical arrows on the horizontal graph. But in this case, it's actually adding them up together and recreating your drawing. How cool is that? Yeah, you can change the speed and the number of vectors. So if you, yes, obviously the more vectors there, the more accurate the pattern will be. But in this case, you will have gazillion of them. So what was the question? In the Fourier transform visualization, so how is the complex shape or pattern being created? Yeah, by summing rotating vectors called epicycles. By overlapping static geometric squares, no. By applying simple linear regression, no. By using random noise generator, no. So must be, yes, that's right. The visualization demonstrates how any complex pattern can be decomposed into and rebuilt from simple sinusoids represented as circles. Yeah, so you can, if you're doing a circle, no, even if you have a complex shape but only one vector, it will be just doing a circle in the center of mass, whatever it is. So if it's a circle, then it's kind of will be replicating the circle. For it to represent better that shape, you need to add more vectors. So now it's doing like an, yeah, if you have two vectors, it will doing like an elliptic shape. Yeah, like that. So any shape, regardless how complex it is, will be represented by an ellipse with just two vectors. You can see how they being added to one another there. Yeah, three vectors will be generating this more complex shape, like a bean shape. Is it a bean shape? Yeah, so if you had a bean shape, then it will be, yeah, anyway, I can't draw properly. But if you had about 10 vectors or so, it's becoming fairly accurate in terms of representing your drawing. This is turning it into frequency domain, adding those vectors up and recreating your amazing drawing. How good is that? Let's see, next question. Smartphone neck simulation. Yeah, that one wasn't great. I'll probably redo it at some stage. But yeah, the smartphone. Oops. Smartphone neck. Yeah, there was another Fourier analysis visualization. Smartphone neck. There's a demo. It's nice to have a demo so I don't have to click on anything. The smartphone neck simulation demonstrates that the load on the neck increases as the head performs which action? Tilts forward, remains in natural upright position, tilts backward toward the shoulders, rotates left and right, tilts forward. Yeah, it's like when you're holding a phone. Let's move on. What is the primary difference between deterministic AI and generative AI as explored by BioniChaos guide? Yes, we had. Wait, first of all, let's do one by one. Pop it in the chat. Go check out the simulation yourself. Yeah, we had this guide on. Yeah, I'm not sure the search. The search is not great, which is better. Use the browser search. Yeah, so we did have this guide, predictability versus creativity, blah blah blah. The difference between what is the primary difference between deterministic AI and generative AI as explored in this guide? Speed of processing, no. Predictability versus yeah, obviously predictability versus creativity, but then yeah, deterministic is predictable, generative is creative. So it's a weird question. Yeah, the phrasing of the question is a bit wrong. But we can do more on that. Yeah, we'll skip that one. How many years? Yeah, so go look up this blog. Essentially, it's like an interactive blog on AI types. Let me know if you have any questions. Have this EEG. Wait, I have to remove stuff from the search. EEG. And the question, yeah, we have a lot of EEG content, brainwave activity and stuff. How many years of EEG history did BioniChaos celebrate in the recent content? Yeah, so it's 100 years since the source material specific 100 years of EEG. Marking a century since its discovery, yeah, since the discovery of EEG recordings. How good is that? And yeah, we had a blog for that somewhere. Yeah, this was like original AI. It was 3 years ago, 2.5 years ago. AI generated images. Now they're obviously much better. Yeah, you can probably tell. No, obviously you can tell, but I'm saying you can probably tell how old of an image generation model that this was. But yeah, look it up as well. Okay, what we're doing? We're doing this AI quiz. Yeah, I was saying we have a lot of content on EEG, so no surprise that one of the questions in the quiz, that notebook LM. So Google, this video is sponsored by, brought to you generously by Gemini models. What's the purpose of eigen faces simulation on BioniChaos platform? Yeah, we do have an eigen faces simulation. Eigen faces, yeah, this one. It will need my camera, so I have to load it in another browser. Yeah, that's what the tool looks like. Hey, the purpose. Let's capture some faces. Just move some eyebrows. So it captures just the eigenvalues from the faces. So it's not storing the original face. And this recreated image, can you believe it or not? It's just based on these 4 eigenvalues. So they're not the original images. It's able to reconstruct my face. Pretty sure. Double check the code. The code is on the page. But it's able to reconstruct. So this is varying based on that first eigenvalue. Is it the second one? There's some weird thing. Well, that's probably because I moved or something. That's the third one. You can automatically automate all of them, and it reconstructs the face based on this eigenvalue. So what was the question? What is the purpose of eigenfaces simulation on the BioniChaos platform? Which, by the way, you can go check out on BioniChaos/PCA. And again, the question, what's the purpose of the simulation? To edit photos using artistic filters? No, even though it's probably is doable with eigenvalues, with eigenfaces. To generate realistic 3D avatars for video games? Well, it's yes to generate avatars, but it's not 3D, it's not for video games. To explore facial recognition using principal component analysis? That's a yes, that must be it. And to detect deepfake videos in real time. We actually have another tool for that, which actually measures your heart rate using the camera alone. But yeah, this specific one is to explore facial recognition using principal component analysis. PCA, principal component analysis, is used to extract the most important features, eigenvectors, from a set of faces to simplified computer vision tasks. So that's exactly what it's doing. And yes, you can use it on this one on your own face, take a few photos. It will extract those eigenvectors. You can see a representation of them. So essentially, it's just focusing on the features that change between the images taken. And then you can change your face yourself. So this is a synthetic face that being reconstructed from these maths. Mathematical values from these vectors. How good is that? Let's move on to, let's see. Let's move on to the next question. And did I share? Yes, I did. Blah, 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 blah. Yeah, there is a human in the loop. There is a human in the loop, just in case you had anything. You had any comments or something? see. Let's see. Do it. One sec. Okay, let's move forward for a sec. The prosthetic arm simulation. Prosthetic arm simulation. Yes, we had a prosthetic arm simulation. We have a demo for it. So it's kind of nice. You can change the speed. It's a 4 degrees of freedom. So it has shoulder yaw, elbow pitch, wrist pitch, gripper. You can just automate it. It'll have some sort of sound to it as well. It sounds this well. And what was the question? The prosthetic arm simulation demonstrates concepts in robotic manipulation, specifically focusing on which of the following: neural tissue regeneration, no; material science of synthetic skin, no; wireless power transmission, no; 4 degrees of freedom, forward kinematics. That's right. The simulation uses 4 degrees of freedom to show how joint angles determine the final position of a prosthetic hand. How good is that? Yeah, let me know if you want me to cover any specific tools on the side to let me know. Let's move to the next question. In the context of EEG, so EEG of the resource measure, what does impedance primarily affect? Impedance. Yeah, well, I had this a super old blog. I don't know why it picked up on it. In the context of EEG, what does impedance primarily affect? The physical, and the options are the physical weight of the headset, obviously not. The color of the brain waves of the screen, no. Even though the impedance can be represented in different ways, the signal quality and noise levels, yes. The speed of light through the sensor cables, no. Those are not optical. It's not optical data transmission or anything. So yes, it's signal quality and noise levels. And that's correct. The impedance at the electrode skin interface can lead to increased noise and poor data quality in brainwave recordings. So that's right. That's an interesting question there. Which medtech startup is featured as a case study involving a revolutionary epilepsy diagnostic tool that faced a recall? Neurovista? No, that one died by itself. Neuralink still supposedly going, but probably Musk gonna kill it just by being affiliated with it. Garmin is not doing epilepsy diagnostic stuff. Biomedical is the one. That's right. The case study explores the rise and fall of this company, detailing its innovation in diagnostics followed by a major recall. That's right. It's funny because I was only able to answer the 10 out of 12, so I answered 2 incorrectly. Oh, 1 wrong, 1 skipped. Okay. And that would be an easy quiz, I imagine. Right, so that was one of the quizzes. We have another one. Wait, if I got back to the first quiz we did, yeah, it's giving me quiz complete. You did it. You got 10 out of 12. 1 question skipped, 1 answered incorrectly. That should be fine. There is another one. Let's see what the questions are like. There's some interesting questions that it generates. It's really nice. Thank you very much. Wait a second. We'll have to load it on a. We'll load it again. Yeah, so this one here, it's the remote PPG. It's a remote photoplethysmography. Don't try pronouncing it at home. You break your tongue. The remote PPG technologies such as the real-time signal amplification remote PPG, RPPG technologies such as this real-time signal amplification microphone detects heart rate by analyzing which of the following: micro expressions on facial muscles, no; small vibrations in the head detected via accelerometry, no; infrared heat signatures from the carotid artery, no, we don't have infrared camera anyway; subtle changes in skin tone caused by blood flow, yes, that's correct. RPPG uses Eulerian video magnification to visualize the minute color variations in the skin that occur synchronously with the cardiac cycle. And yes, it can be. I think we need to. Yeah, the camera was doing this white balancing, which we need to turn off. To turn off any automated stuff. Let's see if we can get a decent signal. Yeah, I was kind of looking in on 63 before. 63 bits per minute. Sounds like right. And you see some signal in there. Yes, it can be improved. It can be improved quite a bit. Yeah, you can test it out yourself on your own head, see if it detects your heart rate correctly. And when you do it, compare it to a smartwatch or something to see how close it is. Or if you have a chest strap, that will be even better. What is often the real bottleneck in building life-saving data science products? Wrangling and cleaning messy raw dataset? Yes. The lack of available GPU power, maybe. Securing venture capital, maybe. That, yeah, the bottleneck with computing power and venture and funding and stuff, that will be the case in many fields. The complexity of neural network architectures, yeah, same. But yeah, that's kind of more specific. Real bottleneck in building life-saving data science products, it's, yeah, cleaning messy raw data. That's correct. Yeah, okay. So yeah, we made this cochlear implant simulator quite some time ago. Can check it out on the site. Yeah, you can choose your number of electrodes, the array. Let's put it in full screen. Yeah, the array type, linear or spiral, fixed scale, auto scale. For the spectrum y-axis, a number of electrodes. So normally it's 20 something, but you can go up all the way up to 40. Change the noise gate. Yeah, it's doing something. There's a problem that, yeah, the y-axis doesn't have labels. We'll disable it for a sec. So, yeah, you can change your color scheme. Ocean, what do you like? Ocean, sunrise, sunrise. It's a weird color. It's a nice color. You have rainbow. Obviously, you have rainbow. Obviously, you have a rainbow. But yeah, that sunrise was actually a nicer color. Okay, and the question was, when it first switched on, what is the common reality for cochlear implant recipient compared to popular viral videos? Yeah, in these viral videos, it's normally been shown how great their hearing is, how all of a sudden the recipient can hear their loved ones and how amazed they are. The reality might be a bit different. And the options are immediate clarity and perfect speech recognition, robotic sounds and general confusion, intense pain caused by electrical overstimulation. Yeah, that wouldn't happen. They will be tuning it up and only increasing the intensity of the current stimulation if needed. But they will be studying a low current stimulation to begin with. So C is definitely not the answer. So there will be no pain caused by electrode overstimulation, because there will be no overstimulation because they start at the low current levels. Complete silence until the software is updated. That would be fine if you had a cochlear implant and it wasn't ready for, with all the software and stuff, and you had to wait for whatever Microsoft Android update or something. No, you don't wait for the software to be updated. So you're not in complete silence until the software is updated, unless they mean like the tuning up of the stimulation parameters. That could be, that might need some time to figure out. When Okay, let's read the question again. When first switched on, what is the common reality for cochlear implant recipient compared to popular viral videos? What's the common reality? Immediate clarity, no. Robotic sounds and general confusion. Yeah, that would be robotic sounds and general confusion would be it. That's right. The journey often starts with robotic sounding audio as the user begins the long process of auditory rehabilitation. That sounds like right. That sounds like right. This is now a question about the eigenfaces. I already closed that one. Is there a link between eigenfaces and cochlear implant stimulation? Maybe. But no, that's not what the question is. In the context of eigenfaces stimulation, which mathematical technique is used to extract the principal component analysis of facial features? Fourier transform? No. Principal component analysis? Yes. It's kind of a silly question because is the answer given away? Yeah, the answer was given away in the questions. That's silly. That's silly. Advanced EEG simulation. Yeah, so we have a lot of EEG simulation stuff. EEG. So you go landing page, neurological EEG, neurotools. You have this EEG, advanced EEG signal simulator. Go check it out. Check it out. Put it in full screen. Yeah, I had some like old notebook LM description of what it does. We can listen to that. It's like 12 minutes. And the question, the advanced EEG signals. There's a demo. You can start the demo, so you don't have to click on anything. It will change the parameters for you, if you like. If you like. And the question is, advanced EEG signal simulator allows users to customize brain waves, including beta, delta, alpha, gamma. Which of these is typically associated with deep sleep? That's a good question. Good question. Well, you can go deep sleep and you have the delta. Delta it is. Yeah, you can use this tool to answer these questions. Can use this tool to answer these questions. So what was it? It was delta. Delta. Yeah, deep sleep will be mainly delta, light sleep, beta, relaxed meditative mainly alpha, and you can see an example of what the waveform will look like both in time domain and frequency domain. And focus concentration, you'll have beta mostly active. So in deep, what was the question? Deep sleep, yeah, beta. No, delta, sorry. Yeah, delta. Delta waves are the slowest brain waves and are the hallmark of deep non-REM sleep. Cycles. And the rest of the questions are a bit funny. We have an interactive We'll do a video. This will be Notebook LM. Just given the YouTube channel and the website. Let's see what it got to say in its defense, whatever Gemini model it is. It's still downloading. It's like 40, 45, 47. Okay, we got it. We got it. Okay, I'll play it in the loaded in the browser. 9 minutes. Can we handle 9 minutes? Well, under 10 minutes. Under 10 minutes. Wait, I have to mute myself.
Welcome to this explainer. Today, we're taking a guided, over-the-shoulder digital tour of a truly incredible ecosystem built by a biomedical engineering PhD. And just to give you the most authentic look possible, every visual we are pulling up today is a direct screen grab straight from the BioChaos content itself. So get ready, because we're about to decode the complex systems that make up the human body and the raw data that drives them. Okay, here's our roadmap for today's exploration. We'll start by mapping out the sandbox itself, then move into how this platform visualizes invisible signals. After that, we'll hit the hard reality of AI and data, discuss the very real ethics behind these technologies, and finally, look at how the platform gamifies hard science. Part 1. The Biomedical Digital Sandbox, Mapping the Chaos. So let's dive right in by pulling up the main navigation menu. Right off the bat on the homepage, the sheer scale of tools designed for researchers, educators, and students is just mind-blowing. We've got entire directories dedicated to neurological tools for EEG, cardiovascular sections mapping out heart rhythms, plus biomedical imaging, vision, hearing, and even artificial intelligence. It brilliantly illustrates the breadth of the platform. We are talking about organizing everything from your brainwaves to your muscle activity into these clickable, interactive directories. It's essentially an entire university biomedical lab, condensed right into your web browser. Now, to really understand a platform like this, you kind of have to understand the mind behind it, right? Looking at the creator's bio, their core mission is refreshingly simple. I'm a biomedical engineering PhD, making hard science fun and visual. This isn't about hiding behind dense academic jargon. It's about breaking down massive, incredibly complex datasets like intracranial EEGs or cardiac rhythms into accessible visual sandboxes. They are taking the notoriously difficult world of signal processing and bioinformatics and turning it into something you can literally just play with. Moving on to part 2. Visualizing the invisible, seeing the signals. Let's actually look at one of the site's most fascinating cardiovascular tools in action. The tech behind their non-contact vital sign monitor is called remote photoplethysmography, or RPPG. Think of it as a real-time signal amplification microscope. By using Eulerian video magnification, it detects the absolute microscopic changes in your skin tone caused by blood pumping through your veins. This means anyone can measure their heart rate just by looking at their face on camera. You're visualizing an entirely invisible physiological process.
By the way, I'm pretty sure I did ask you to pull screen grabs from the website, and it just ignored me and generated its own graphics. I don't know why, but okay, actually not too bad.
Using just a completely standard webcam. It's wild. And you can really see the creators' genuine excitement about democratizing this advanced tech in their updates. They were thrilled to announce the tool was detecting heart rates with good signal quality. The takeaway here? You don't always need a hospital full of expensive hardware to do real biomedical monitoring. The explicit goal is to make this accessible for researchers, developers, and honestly, anyone who's just curious about how their own body works. But it goes way deeper than just capturing the data. It's about understanding how that data actually behaves under different conditions. Take the PulseViz simulation. When you launch it, you literally become the engineer. You manually adjust the baseline heart rate, you tweak the oxygen saturation, and you can even crank up the background noise levels. By doing this, you observe the real-time changes to the waveform right on your screen. You get to see exactly how something like noise physically alters a heartbeat signal quality, which is just a fundamental lesson in biomedical engineering. Now check out this EEG device comparison tool. This is great because it lets users filter hardware based on signal quality versus cost. Sure, a consumer device might have a nice low price, but you're trading that off for a low to moderate signal-to-noise ratio. If you want maximum SNR, meaning the absolute cleanest brainwave data possible, you're looking at implantable devices. And those obviously come with the highest price tags and the highest level of invasiveness. It really grounds all those flashy simulations in the very real-world constraints of hardware budgets. All right, part 3. The AI and data reality. Behind the shiny demos. Clicking away from the simulations for a second, we enter the dense, sometimes frustrating back-end reality of data science. We have to ask the elephant in the room. How do we actually know the data feeding these simulations is clean and reliable? It's arguably the most critical question in the entire field. Algorithms are literally only as good as the numbers you feed them. And the creator of BioniChaos has a very grounded and pretty funny reality check about this. It all comes down to what they call the developer's dilemma. On one hand, everybody wants to push the big red button that says, develop life-saving product now. We all want the glossy AI integration and the viral demo. But on the other hand is the brutal reality. 6 painful months of cleaning a data set that looks like it's been through 5 wars and a spreadsheet crash. Look, nobody wants to clean up duplicate records from 2013 or fix broken column headers, but without doing that grueling work, the shiny product is utterly useless. Following up on that exact dilemma, the creator dropped this passionate rant, and honestly, every data scientist should probably frame this quote. Garbage in still means garbage out. It is a vital reminder that great products aren't built on clever code, they are built on clean, reliable, boring data. You absolutely cannot automate away bad foundations. You cannot, as they so perfectly put it, machine learn your way out of a data dumpster fire. It really highlights the immense invisible labor that goes into platforms like this before a single simulation can run. And when talking about AI in general, the creator drops this highly philosophical take. Instead of buying into the standard tech hype, they present AI as a fundamental property of the universe. We didn't create intelligence, just as we didn't create math. Both were simply discovered. It totally reframes how we look at the artificial intelligence tools embedded throughout this sandbox. They aren't magical thinking machines, they're complex mathematical landscapes that we are just now learning how to navigate. Which brings us to part 4, ethics and human impact, the human element. When you dig into the platform's literature and reporting tools, the ethical complexities of these biomedical advancements get very real very fast. Just look at the report on AI-enhanced brain-computer interfaces. It starkly lists the heavy human implications of literally putting hardware inside the skull. We are dealing with massive data privacy concerns, like who owns the data coming straight from your brain. There are thorny issues of informed consent, huge questions about equity and access, and deep philosophical questions about whether merging with AI actually causes changes in personal identity. We see this clash between expectation and human reality, perfectly illustrated in a really poignant post about cochlear implants. We've all seen those viral internet videos of someone hearing for the first time, crying tears of instant joy. But BioniChaos provides a vital reality check. The difficult clinical truth is that activation often starts with robotic, overwhelming sounds and total confusion. The brain actually has to learn how to interpret these brand new electrical signals. As they say, it's a journey, not just a switch. And true to the platform's DNA, you don't just read about that confusion, you can actually experience it. The sandbox features a cochlear simulator. You can launch it to visualize the exact electrical signals being sent to the brain by an implant. Then, you can adjust the parameters and acoustically experience those robotic, sometimes distorted sounds yourself. It bridges the gap perfectly between studying a medical device on paper and actually having empathy for the patient who has to wear it. Finally, part 5, making hard science fun, where we gamify the chaos. So diving into the interactive games available in the sandbox, I need to stress, these aren't just your standard web toys. They are deeply educational tools. You have Cardio Quest, which literally pits your pattern recognition skills against a robot algorithm to score points by identifying abnormal ECG heart patterns. There's Dopamine for testing reaction times, BSIM to explore how simple rules create complex swarm intelligence, and even a fully interactive CRISPR simulation lab. They take incredibly dense subjects and turn them into compelling, playable challenges. Seriously, look at the CRISPR simulation lab. By breaking down complex biological processes into interactive, step-by-step tasks, concepts like gene editing suddenly feel as accessible as a web game. You literally enter your target DNA sequence, input your guide RNA, specify the edit, and execute the simulated cut. It takes a Nobel Prize-winning technology and puts it directly into the hands of a student with a web browser. It completely demystifies the mechanics of genetic engineering. The platform even bridges the gap into psychology with a tool called Mental Lang. Here, they are applying hard engineering frameworks to the human mind itself, stating that mental health is a dynamic system. By using concepts like signal processing and simulations, the goal is to model the complexities of our psychology to gain better insights into well-being. It is a wildly innovative way to look at mental health, not just as an abstract feeling, but as a dynamic, measurable system that we can visualize and understand through an engineering lens. As we log off this incredible platform today, we're left looking at an interface that has shown us the hidden, inner workings of our hearts, our brains, and even our DNA. BioChaos really proves that the invisible forces driving our biology are, at the end of the day, just data waiting to be visualized. So it leaves us with an inspiring challenge. If we can build digital sandboxes to decode everything from our brainwaves to our genetic code, what invisible system will you choose to decode next? Thanks for exploring the data with us today. Keep questioning, keep visualizing, and keep learning.
can't feed these slides that the notebook LM made. We'll actually download it. We'll download it, load it in the browser. Right, let's see. Let's see. It's actually pretty good. It's actually pretty good. BioniChaos structuring the nodes. Okay. Cerebral cortex. Some random stuff around the EEG channel 1. Noise reduction. Okay. It's a bit weird. Making how biomedical science visual, interactive, and accessible. That's what we do. That's correct. Ooh, the bottleneck is modeling. It's the swamp of raw data, garbage in, meaningful output. It's meant to be garbage in, garbage out. Develop life-saving product now. Yeah, it's taking some meme or something we posted. You cannot machine learn your way out of data dumpster fire. Behind every shiny product demo is the grueling work of formatting duplicate records and missing values. Is that what that represents? Great insights require clean, interactive foundations of a clever code. Is that meant to be clever code? Signal integrity, data resolution, analysis latency. Analysis latency, okay. Ooh, 7. It's a bit convoluted. BioniChaos core, cardiovascular, neurological, AI simulations, AI, audio and vision, perception, signal processing. It's actually pretty accurate. I don't know what all the other lines there for, but okay. This is, by the way, slides that Notebook LM generously generated for us. 50 plus interactive simulations, bridging engineering, clinical language, and human biology. And that's about right. A massive repository designed to democratize biomedical data, transforming static data files and equations into dynamic models for researchers, educators, and students. Yeah, sounds like it. Whoa, what just happened there? Well, first of all, didn't load the slide properly. That's actually pretty good. I like the visualization of it. From 100 years of EEG history to modern 3D brain mapping and seizure detection algorithms. Okay. Interactive brain-computer interface tools that allow users to customize brainwaves, simulate clinical artifacts, and visualize both time and frequency domains in real time. The visualization, let's see. Does it make any sense? Is that how tools should look like? I like the Microsoft, the X square line thingy. That's kind of redundant. Well, especially because we're doing web apps, so they don't need that, do they? Advanced EEG simulator, Delta. Yep. Yeah, we have something very similar to that, so that's okay. NeuroVis 3D, so you have some sort of neuron with some sort of action potentials or whatever neural activation going on. It's kind of nice, but not sure what you meant to do with it. Like, should be able to like move through the brain in 3D or something? See how neurons are connected. Seizure zone. Yeah, we have something very similar. Yeah, what we have is actually better than that. Yeah, look it up on the site. Let's move on quickly. Is it loading the slide correctly? This weird thing. Yeah, it's doing some what's that? Some pretty amazing graphics. They're like publication level, that's for sure. There's nothing too wrong with them. Let's go over this one. Well, there's nothing too wrong with them, on first glance. Turning webcams into non-contact vital sign monitors. Yeah, that's what we're doing. Eulerian video magnification focus area. It's actually meant to be on the forehead. If it looked at the website, it would have known that. Frame rate, 30 FPS. Is that a better? That's probably better user interface than what we have. Resolution 1080p, blah, blah, blah. Frame rate. Why the resolution is that twice? Ooh, that's actually, it's extracted the waveform, signal quality good, a region of interest selection and tracking, Eulerian video magnification, signals extraction and filtering. Okay, I'm not sure about the errors, there are too many errors. Estimated heart rate 72 BPM, so that's in our case, it's actually indicated on the forehead. And you have confidence level of 95%. I think it's also indicated somewhere on top of the face. Remote photo plethysmography, RPPG, in the browser. That's what we do. We have a tool like that. Go check out BioniChaos.com. Visualizing the invisible micro changes in skin tone caused by blood flow to extract accurate heart rate data without physical sensors. That's right. Yeah, and the waveform there looks interesting because maybe, supposedly, it has a dichrotic notch, which actually indicates a really high signal quality. Yeah, signal quality good. You have dichrotic notch in there. We don't actually see a clear dichrotic notch. Well, at least I wasn't able to convince myself that there is a distinctive dichrotic notch, which you normally get with like clinical grade PPG sensors, normally like the finger one. What else we got? Deconstructing human perception through interactive physics and visual mechanics, simulating the mechanics of our senses from the tonotopic mapping of auditory hair cells to the neuroscience behind visual motion illusions and depth perception. Yes, we have a what's Troxler? Is that a thing? We have a visual cortex interpretation. We have a lilac chaser illusion running on the side. You can check it out. I don't know what that fading is. We have some parameters that you can change about it. And what's this one? Cochlear electrical mapping. It's good. That bit is really impressive. That side of the graphic, 10 hertz, 4 hertz, 1 hertz, 400 hertz, apex, base. That should be legit. Yeah, that's like stretching out the cochlea and cochlear electrical mapping. Yeah, that one's a bit weird. Yeah, I'm not sure about that bottom one. I understand what it's trying to do, what it's trying to say. But yeah, it's just kind of covering in general the topics that we talk about. Yeah, so there's cochlear electrical mapping and optical illusions that are used a lot in the neuroscience for determining how your brain and the vision system works. What else? Ooh, temporal resolution. Is this even accurate? So you have EEG, ECG, FNIS, EMG, PPG, low spatial resolution. I don't know if it's accurate or not. And what's the size? Yeah, so it's not meant to be taken face value, is it? It's just for illustrative purposes. We do have a similar graphics that actually should be accurate on the website. The multimodal medical data landscape, a definitive guide comparing the primary biomedical signals, highlighting data gaps and strategic pathways for integrating physiological into cardiovascular and neurological web applications. Whew, that's a mouthful. It doesn't really mean much in this case. For deconstruction, it's kind of, yeah, visualizing the mathematical magic of real-time signal analysis in the browser. Time domain signal for a deconstruction, frequency spectrogram. It's fine. Yeah, these graphs, they look like hyper-realistic, but they're actually meaningless. The math behind the magic, decomposing complex noisy biological patterns into simple sinusoids using real-time audio analysis, wavelets, and Fourier series. So I understand what it's trying to do. It's meant to be showcasing it like in general terms, but these graphics kind of have too much details, so they're kind of proposing that they are accurate, or the details in them are valuable. They actually are not. But yeah, very interesting. I haven't seen this type of graphics that AI generates. Dopamine UI, CardioQuest. Yeah, we do have all these tools. I don't know why it's trying to. It seems to be trying too hard now. Generative AI bridges the gap in complex engineering concepts and clinical application. Deterministic. Complicated. I don't know. Yeah. Anyway, yeah. Go check the website. We have a tool like that, but it's actually accurate. I don't know why it had to make stuff up. I was actually asking it to go and like explore the site and actually extract like print screens, screen grabs, like page grabs from the site, but it's actually generated its own stuff. I'm not sure why. Yeah, so many subscribers we have, so thank you for subscribing. There are lots of videos, 1.4 thousand videos. That must be right. We're doing open source hacks. Hacks, never called it hacks, but okay. Unscripted live streams, yes, and a community of data wranglers, okay. Never called it that, but whatever. A space for the unsung hero, blah 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 blah. Real-time eye tracking, AI coding. Yep. That's all there. We don't just analyze data, we experience it. Explore 50 plus interactive simulations. Stop sweating in front of the wrong button and start structuring the noise. Okay. I'm not sure what to make of it. But thank you, Notebook LM, for indirectly sponsoring this video. Whatever. Yeah, very nice, very nice. Yeah, go check out the website. Everything we do is available on BioniChaos.com. Provide your feedback. And I'll see you next time. Bye. like this clean window of there is a new button in Visual Studio Code, open in agents. And it's actually this nice clean window. It's very nice, very nice. It still doesn't fit my smaller screen very well. Wait, isn't it meant to just have automated model selection? I think it should just have an automated model selection. Yeah, yeah. Not sure. We'll test it next time.